Today we are going to see about the mutual inductance of the coil. The mutual inductance is defined as the ability of one coil to produce EMF in other coil by induction when the current in the first changes. It is also defined as the Weber turns in one coil per ampere turns in another coil. It is measured in Henry. Consider the circuit shown in figure. If varying voltage source V1 is connected to the coil 1, it produces a varying current I1. Let the number of turns in the coil 1 be the N1. The number of turns in the coil 2 will be N2. The varying current I1 in the coil produces changing the flux Phi1 in it. The flux Phi1 is divided into two parts, Phi1 equal to Phi11 plus Phi12, where Phi1 is a part of flux Phi1 which links only with coil. Phi1 is a part of flux Phi1 which links both coils 1 and 2. Let the induced EMF of coil 2 E2, the induced EMF E2 is proportional to the rate of change of flux in the coil 2. E2 is proportional to d phi 2 by dt, therefore E2 minus N2 by N2 into d phi 12 by dt. N2 is the number of coil turns in coil 2, d phi 12 by dt is the rate of change of flux link coil 1. The induced EMF also proportional to the rate of change of current causing the flux Phi12. So the current causing the flux Phi12 is I1. Therefore E2 is proportional to dI1 by dt, that is E2 equal to minus M into dI1 by dt, where M is mutual inductance between coil 1 and 2. dI1 by dt is the rate of change of current I1. Equating equation above equations we got minus N2 d phi 12 by dt equal to minus M into dI1 by dt. So M equal to N2 d phi 12 by dt. At constant permeability M equal to N phi 12 by I1. If the voltage source connected to the coil 2, the circuit becomes shown in figure. So varying voltage V2 produces the varying current I1. Let the number of turns N1 and number of turns N2. So varying I1 coil produces a flux Phi1. So the Phi2 equal to Phi22 plus Phi21, where Phi2 is a part of flux Phi2 links with the coil 2. Phi21 is a part of flux Phi2 links with the coil 2 and 1. Therefore E1 is proportional to d phi 21 by dt. Therefore E1 equal to minus N1 d phi 21 by dt. So the current causing flux phi 21 is I2. So E is proportional to d phi 2 by dt. That is equal to M equal to N1 d phi 21 by dt I1. When the permeability is constant, M equal to N1 phi 21 by. So coefficient of coupling is defined as the fraction of total flux produced by one coil linked with other coil. So K equal to phi 12 by phi 1 equal to phi 21 by phi 2. So substitute the phi 12 by phi 1 phi 2 we got M square N2 phi 12 by I1 N1 phi 2 by I2 we got and also N phi by I. So M squared equal to K squared L1 into L2. Therefore M equal to K into root of L1 L2. The maximum mutual inductance occurs when K equal to 1. Therefore M max is equal to root of L1 and L2. Okay, thank you.